Welcome to Harry Potter and the Graph of Centrality, presentation on web analytics using two centrality metrics on Harry Potter datasets. My name is Rafal and I'm representing Team 3. A few words about the datasets. There are two. The first one represents the relationships between characters, and the second is their affiliation. We will also leverage our knowledge of the book and what the affiliations stand for to mark the characters either good, evil, or neutral. The data was obtained by scraping the Wikipedia and using a publicly available dataset posted by another fan. So what are we going to do? First, we'll load the data, then clean, map, and expand it. Then we will create a network X graph object, calculate degree centrality and eigenvector centrality. We will then compare the metrics for each of the categorical features. And finally, we will visualize it as a graph and interpret the results. Here we have, we're loading the data and creating a data frame with a complete list of unique characters from both data sets. We have 187 total. We then create a new feature side and map it to each character based on their affiliation using this dictionary. And you can see that Death Eater affiliation is marked as evil. The other four are marked as good, and what the characters without an affiliation are marked as neutral. And the sample contents are shown here. We could save this now and load it going forward for more efficiency, but we are showing that number one, the data always needs transformations and polishing. And two, there's more to your data if you know the subject. You can engineer new features. Moving on to the network analytics, we leverage Python's network X package. First, we initialize a graph object and assign nodes as characters and edges as their relationships. We then set affiliation and side as attributes to each node. Sorry, it's actually here where we set the attributes. And we move on to the centrality algorithms. Degree centrality represents the proportion of all connections. And eigenvector centrality is similar, but it's weighted and directed. So what do we do with it? First, we assign it to the corresponding nodes. So we set the attributes, but we also create a data frame with our categorical variables, affiliation and side, and the contents are here. So we have, so now we can aggregate the mean and the sum of the values and compare them. And this is what we end up with. On the left side, you have the mean or the average influence. And on the right side, you have the total influence. We can see that the average influence is almost equal to for both good and evil. But when we take the total influence, the evil side is only a fraction of the influence of the good side. And we do the same thing for the affiliation. And we can note the power of the order of the Phoenix and the influence of its members, and that it's almost twice as large as the members of the dark side, Death Eaters. Now that we know the numbers and we're starting to formulate a story for a better picture, let's visualize the network itself. So first we set the color coding, The side of the characters and their affiliation is represented using colors. And the two metrics that we just computed, the centrality measures, are represented as the size of the nodes. And we simply assign it to a list. And here it is, as expected. Harry is right in the middle as the good guy, and Lord Voldemort is as the bad guy. And we can dive deeper into the graph. And also another color-coded representation is Dumbledore's army, marked as blue nodes. It appears that they don't have that much influence within the story as expected. I'll zoom into the graph a little bit so we can dive deeper and we can ask additional questions, such as who is most likely to join the Dark Lord. Let's focus on the characters in the upper half of this graph and the characters that are marked as neutral. You can note some characters here. So, for example, Narcissa, she is Draco's mom. Lucius's wife. She's friends with Bellatrix, and she also has a direct connection with you-know-who. So we can simply assume that she's most likely to, or more likely to, join the dark side. The point here is that the characters much closer to the red group are more likely to join the Dark Lord than, for example, characters on the bottom of the graph, such as the Dursley family or Hagrid's pets. They're affiliated with or closely related to the green side. Now let's focus. Let me just remove this, and let's focus on the characters, on the red character right in the middle of the green group, Peter Pettigrew. In the book, he is a Death Eater, and he morphed into a rat and became Ron's pet. So he's a Death Eater. We can create this connection here, and he was Ron's pet. So ultimately, he is spying for Lord Voldemort on the green side. He's also friends with Sirius Black, Lupin, and Severus Snape. Now, the case with Severus Snape is also interesting because we know that he is a Death Eater, but we also know that he is loyal to Dumbledore. He loved Lily Potter, and ultimately he protected Harry. But he is spying on Lord Voldemort. So we can see that there are two spies right in between the groups. And that's it. To conclude, we leverage categorical features to highlight different groups, and we leverage centrality measures to determine how influential the characters are. Thank you.